Hey there, advanced math. Going to work today on finding the volume of rectangular prisms with fractional side lengths. We've kind of done this the last couple of days with two different strategies with whole number side lengths. And today I want to kind of talk about what happens if some of the side lengths are not whole numbers. So write this as the title of your next free page in your math notebook. Mark a page, close it up, unpause, and follow with me. So just a reminder, we've been talking about geometry for a couple of weeks now. 2D figures, the measurement around the outside of the figure we call perimeter. You measure sort of, around the outside of the 2D figure. And the inside of the figure we would tile and count square units, and we call that area. On a 3D figure, they don't really have perimeter since they have 3 dimensions. So what happens is, on the outside of the figure, there's entire 2D figures surrounding the 3D figure. There's a rectangle on the top, rectangles on the sides, rectangles on the bottom, squares on the front and the back, and we would find the area of all those different pieces. So the outside of it, on a 3D figure, the way we measure the outside is surface area. And then the inside, we learned how to kind of pack with cubes and count how many would fit in there, and we called that volume. And so this gets measured in things like centimeters and inches and all that. Area gets measured in square centimeters, because they make squares. We measure it in square units or square inches. So does surface area. And then volume gets measured in cubic units, centimeter by centimeter by centimeter cubes or inch by inch cubes. So they get measured in cubic units. And that's just kind of what they are. All right. 2 ways to find volume when we have a side length that's not a whole number. One you're probably never going to do, but I want you to think about it. And then the other you'll probably always do, and I just want you to know why it works. So if I were to find the volume of this rectangular prism, again, that means, how many, cubic feet inside would fit inside of this thing. That's what you're measuring when you measure volume. So I would take, if this is 1 foot right here, so what I'm doing is like imagining I'm filling this thing with cubes that are about 1 foot by 1 foot by 1 foot, like I'm filling it up with 1 square foot cubes and figuring out how many would fit in there. So the first thing I could do is just pack it with cubes. I can imagine actually putting cubes in there, right? So I would be looking in one, so this is an easy one because it's kind of a 1 unit this way. So, I would be able to put one that would go all the way against this side, and then I could put another one on top of it to fill the top. And just imagine how many times I would do that, right? And so, if this is 4.5 feet this way, so I can fit 2 up, stack 2 up, and then I would do, 2, 3, 4, sets of that. I'm just going to draw them kind of like that. And then when I get over here, I can't fit any more in, right? Because I'm down to, this is my 1 foot, 2 feet, 3 feet, 4 feet. And so I could fit 2, 4, 6, 8 of them here. But then when I get over here, my blocks are not going to be able to be full units. They'd be only 1/2 of a foot left this way because it's 4.5 feet. So I would be kind of like filling them with half figures. I wouldn't be able to fit a whole one in. They'd be these little skinny things that would look kind of like this. It'd be kind of like a one of these cut in half, right? So this would be a 1/2 unit, and above it I could fit another 1/2 unit, and those would make a whole one together, and so I'd have 2, 4, 6, 8, 9 cubes would fill it in. If you want to think of it, I could fill it with 8 cubes and 2 1/2 cubes. And that would make 9 in total. Now you're probably never going to do that, but I want you to see when I use the formula in a second just why it's still okay even with a fraction. This would be really tough to draw, and probably not my preferred method, but it does work. And so I would probably end up using the volume formula. For a rectangular prism, volume equals the area of the base, we call big B, times the height. So the area of the base is a rectangle, the base of the rectangle, so that would be 4.5 times 1. So that bottom base has an area of 4.5 times the height of the prism is 2, and 4.5 times 2 is 9. And so we got the same thing both ways. So that's kind of a simple basic problem. I wanted to do a basic problem and a more advanced problem. So this has a volume of 9 cubic feet. So here's a more advanced problem. Let's just think one through. It's a little different. So here, a box has a volume of 22 cubic inches. What is the length of the box? So we have an unknown value here. I know the length, and I know the width, and I know the height, and I know the width, but I don't know the length of the box. So what I have here is my volume of this. Again, is the area of the base times the height. And so the volume of the base is going to be length times width of the base. So I don't know the width. So I've got basically it's 1.5. Let's go x first. So it's a length of x times a width of 1.5 times a height of 3 to find the volume. And I know the volume here. They give it to me, right? So it's 22. And I can multiply those and say, all right, well, 22 is going to equal, that's going to be 3 times 1.5 is 4.5. And so I'm going to say that x times 4.5 equals 22. Now, if you think back, I can solve for x here. If you think back to the unit where we dealt with variables, I said, okay, well, if I want to solve for x, I look at what's happening to it, and I use the inverse operation. So right now, x is being multiplied by 4.5. So I'm going to divide by 4.5 on both sides. And if I do that, this is 1. And I get that missing side is 22 divided by 4.5 is 4 8/10 repeating, what is my unit, inches. So a little more than 4 8/10 inches across. And that's it. So that way, sometimes you can do the opposite. Sometimes we'll give you the volume, and you can find the missing side. Since they're all multiplied, you just got to figure out what it is. So that's just a more advanced I do problem. So here's what I want to do. I want to do a basic we do and a more advanced we do. So I'm going to pause for a moment. I'm going to let you do this one. Try it on your own with both packing and formula. I'm going to pause and work it out, and when I unpause, it'll be all set. So draw your figure. Try to practice packing it with cubes that are 1 foot. Again, it's pretty easy because I did 1 foot this way for the example. So only 2 of them are going to fit across the bottom. And you can practice drawing those and then practice drawing the half one. All right, when you unpause, or when go ahead and pause. I'm going to pause too, and it'll be done when you unpause. All right, so here was my best attempt at drawing the cube packing. I drew 2 1 by 1 by 1 cubes on the bottom here, because since this is 2 feet, I'd be able to fit 2 this way and only 1 this way. So those would cover the bottom. And then I just, without even drawing them, I just kind of imagined, like if I went up 3.5, I'd be able to do 2 more whole rows. You know, another whole foot here, another whole foot here. And then I'd have 2 little 1/2 ones at the top. You know, just the top halves of ones. So I figured it'd be 1 whole 2, 3, 4, 5, 6, 6.5, 7 cubes if I packed it together. And then formula was area of the base times the height. So that's 2 this way times 1 this way gave me 2 times 3.5 gave me 7. So I got 7 when I packed it and 7 this way. All right, let's do a more advanced one, different than the last one. Do a real thinker. I found this question. I thought it'd be a really good one. So an aquarium in the shape of a rectangular prism is 12.5 inches long, 6 inches wide, and 8 inches high. I'm going to go ahead and label what I think those mean. I think that means 12.5 inches this way. Wide, I think, means this. So 6 inches that way. And then 8 inches high. What's the total amount of water needed to the nearest cubic inch to fill 90% of the aquarium? So rather than filling it all the way, we're going to fill it 90% of the way. If you want to pause and work this out on your own and see how I do it after, go ahead. Or you can do it along with me. So what I'm going to do, I'm going to find the whole volume. And then I'm going to use a ratio of 90% of that. Is what I'm going to do. So finding the whole volume should be easy since it's a rectangular prism. I can do the volume is the area of the base times the height. So the base is going to be, area of the base is going to be 6 by 12.5. 6 by 12.5 is 75 times the height is 8. So I'm going to go ahead and multiply that by 8. So the volume of the whole thing is 600 cubic centimeters. Is that centimeters? Inches, I'm sorry. Cubic inches. And so now my question is, what is 90% of that, of 600 cubic inches? So I'm going to need a ratio to do that. So remember, a percent's a ratio out of 100. So I'm going to say 90 out of 100, that ratio. I want to know that's the same as, let's see, this is part to whole in a percent. And so this is my whole volume. This is if I filled the whole aquarium. So it goes in the whole spot here. Is to what? I used to put question marks there, but now you know about variables, so I can put a variable there. How about an x? So now I want to know what this is, right? 90 is to 100 as what is to 600. And not too bad to find that 90%, actually, because here I multiplied by 6. So here I need to multiply by 6. 9 times 6 is 54. So 90 times 6 is 540 cubic inches. That's 90%. And then the other 60 is the last 10%. You know, if I imagine I'm filling it 90%, maybe I'm going right to there, and I'm leaving off that other 60 cubic inches so it's not close to overflowing. All right. So that's volume of things with fractional side lengths. Hope it makes sense. If you need to go back and watch any of these examples again, especially the advanced two. I know the easy ones were pretty easy. Please do to make sure those make good sense to you. And after you have done those and taken good drawings and notes on your 2 we-dos, you're all set, and I'll see you tomorrow.